Okay, we will see how the mobile phone works. When you take a voice call, how it is going through the mobile phone. A voice call is an analog signal. So when we call, the signal is coming from our mouth like this. It is analog signal. Then the mobile phone has a microphone. It has a microphone. Yeah. Okay. Then microphone here. This microphone will convert the signal to a digital signal. So any mobile phone, you have a microphone there. Then it is converted to a digital signal. So it is converting by a device called we have another device here, another unit here. That is the one convert this analog signal to digital signal. Actually, microphone convert this signal to electrical signal. Microphone converts to electrical signal. From microphone, the output is electrical signal. It's an electrical analog signal. Analog signal. Then you have a device, another device here. This is called coder. It will convert it to a digital signal. At the receive end, the reverse will be done, that the digital signal will be converted to electrical analog signal using the speaker. At the receive end, that mobile phone has a speaker. That speaker will convert this electrical signal. This digital signal is converted to an analog signal, electrical signal, by using another device called the decoder. The coder will convert the electrical analog signal to digital signal, and decoder will convert the digital signal to electrical analog signal. This is at the receiver. Then we have a speaker. On the speaker, it is going to the air and coming to our ear. So this is how a mobile phone transmit end and the receive end, how it is working. There are some other steps. I will explain that one. So then coder will mainly, this electrical analog signal is converted to a digital signal. The receive end, the reverse of that one, digital signal is converted to electrical analog signal. Normally these two units are together. So it is called the coder plus decoder. And coder and decoder, it said here coder, here decoder. From the coder, I take COD, and decoder, I take the DEC. So this is called codec. So your mobile phone has a codec. So codec will convert the electrical analog signal to digital signal as well as the digital signal to electrical analog signal. These parts are there. The how to convert electrical analog signal to digital signal is analog to digital conversion. So we studied about the analog digital conversion. One method is the pulse code modulation. PCM, where the analog signal you convert it to digital signal. Analog signal has a 0 to 20 kilohertz bandwidth, but you select only the 4 kilohertz bandwidth. Analog signal has 0 to 20 kilohertz bandwidth, but we select only 0.3 to 3.4. By using a filter, we take only this band. This is approximately 0 to 4 kilohertz. So this signal is converted to digital by using the PCM, and the bit rate will be 64 kbps, kilobit per second. But there are some other methods to convert analog signal to digital signal. Another method is called the delta modulation. Delta modulation. So it's converted the voice signal to digital signal at a rate of 32 kilobit per second. Is 32 kilobit per second. So there are some other methods. It has low bit rates, that is 16 kilobit per second, 8 kilobit per second, like that also. There are codecs you can convert to low bit rates. Advantage of the low bit rate is the required bandwidth into the transmission media is less. So I explained last time that the bandwidth is proportional to the bit rate. When the bit rate is decreasing, required bandwidth, the occupied bandwidth is less. So therefore, in the analog codecs, this is converted to some codecs going to a low bit rate. Okay. Any question from this one? Any question? Okay. This is converted to digital only. But inside there are some other mechanism is there. This digital signal you cannot transmit as it is. So what is the transmission media we are going to transmit in the mobile phone?
Wireless analog signal.
Yeah, wireless. That means the free space. Free space is the transmission media we are going to use as to send the signal. So in free space, when you are transmitting the signal, it should be an analog signal. You cannot transmit a digital signal in the free space. The free space, this is going as electromagnetic wave. It is going as electromagnetic wave. So it is a digital, so it's an analog signal. Then this digital signal, again we have to convert to analog signal before put into the free space. This is very important. This digital signal, we have to convert to analog signal before sending it to the free space. Right? Then how you convert this digital signal again to analog signal? Digital to analog. Digital signal is converted to analog signal. How you can do that? How you can convert to a digital signal to analog signal? The method we used is called the modulation. It is called modulation. To convert this digital signal, analog signal, we use a method called the modulation. Okay. Then, what are the modulation methods we can use for convert digital signal to analog signal? These methods are called ASK, I will explain it later, amplitude shift gain, FSK, frequency shift gain, and PSK, phase shift gain. ASK, FSK, and PSK. Amplitude shift gain, phase shift gain, frequency shift gain, and phase shift gain. From these methods, your digital signal will be converted to an analog signal. Now, so you have the microphone, then you have the coder. First you have the mic. Then you have the coder. Then you have the modulator. Modulator will modulate your signal. Modulate. After microphone, this analog signal come into coder. Coder will convert it to a digital signal. Then it is coming to modulator. Then modulate convert it to again analog signal. Now this analog signal is going to an antenna. From antenna, it is going to the now this is the antenna. This from antenna, it is going to the free space. Now there is a constraint here. This antenna size, antenna length depends on the frequency you are transmitting. Antenna length. So normal antenna called Yagi antenna, where we use for the TV receptions. This Yagi antenna, this antenna length is normally half the wavelength. Half the wavelength. Half the wavelength. So we know the equation V equal F lambda. So speed is equal to frequency into wavelength. The speed in the free space of a signal is 3 into 10 to the power 8 meters per second. 10 to the power 8 10 to the power 8 meters per second. Meters per second. So now suppose the signal of 1 kilohertz. Signal of a 1 kilohertz. Let us see. Signal is 1 kilohertz. What is the wavelength? The speed is 3 into 10 to the power 8. Can you check what is the wavelength comes? How much the wavelength? 3 into 10 to the power 8 is equal 1 kilohertz. 1 into 10 to the power 3. Frequency should be putting in hertz, not kilohertz, into wavelength. Then wavelength is equal speed divided by frequency. It is coming in meters. Then what is the wavelength here? Can somebody calculate and tell me wavelength? Three into 10 to the power 8 divided by 3 into 10 to the power 8. That is 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 1 kilo. 1 into 10 to the power 3. That is 1000. Then what is the answer? That will be 30,000 meters. 30,000 meters. That is 30 kilometers. Then the antenna length should be 30 kilometers. Right? Then can you see if it is 1 megahertz signal, what is the antenna length or wavelength? 1 megahertz signal. 1 megahertz, 1 into 10 to the power 6. Can you put your answer here? The wavelength is lambda, correct? If it is 1 megahertz, what is the wavelength? It will be
30 meters.
Yeah, correct. 30 meters. 3 and 8 zeros divided by 1 and 6 zeros. Then it is coming as 30 meters. 30 meters also a big amount. So then you calculate if it is 1 gigahertz. One gigahertz, that is 1 into 10 to the power 9 hertz. What should be the antenna length? What is the antenna length?
0.003 meters.
Yeah, 1 into 10 to the power 9. Then it is coming as 0.03 meters. 0.03 meters. Right? That is, when you multiply by 10, it is centimeters, 3 centimeters. So this is a possible size of antenna. So antenna should be normally half of this one, that is 1.5 centimeters. So normally these signals transmitted in gigahertz range. It may be about 2 gigahertz range. So then this modulated signal, when the modulator you convert to a digital signal to analog signal, then you have to convert it to a high frequency signal. You have to convert it to a high frequency signal. Therefore, after modulator, you need another device here called the RF converter. Radio frequency converter. Okay. This RF converter. The RF converter will increase the frequency from a very high frequency signal. So therefore, in a mobile phone, inside the mobile phone, you have these things: microphone, coder, modulator, RF converter. Then at the receive end, you have the reverse of the coder, that is called decoder. In coder and decoder together is called the codec. At the receive end, it is doing the reverse of the modulation, that is called demodulation. Therefore, modulator and demodulator are together, that is called modem. Modulator and demodulator are together, that is called modem. Then at the receive end, that is again the RF converter is there, that is the reverse side. That is a high frequency signal is reduced to a low frequency signal. Okay. So this is what is inside in the mobile phone for voice communication. So this is common to any system, any transmission, any wireless communication system. After RF converter, you have the antenna. You have the antenna. Then the different antenna types are there. We can study about those things also. Then actually up to coder we discussed. Now today you have to see the modulator, then the antenna, those areas. Right? Any question from here? Okay, one question. So the answer 1 kilohertz should be 300,000. 1, 2, 3, 4, 5. Yes, yes, 300,000 meters. 1 megahertz should be 300 meters. Yes, that is correct. Yeah. 1 gigahertz should be 0.3 meters. Yeah, you are correct. Okay, you have to understand the principle behind that one. So any question from this area, this one? Any question? Okay.